The National Electrical Code Section 400.7a states that flexible cords shall not be used as a substitute for fixed wiring. Section 400.7c says that the connecting of flexible cords from different sources or in a series is not permitted. The Occupational Safety and Health Administration Section 1926.405 says that extension cords shall not be connected to each other. The Michigan Occupational Safety and Health Administration Regulation 408.4196 relates to 29 Code of Federal Regulations 1910.305 states that extension cords shall not be connected to each other. The California Occupational Safety and Health Administration Regulation 8 Code of California Regulations 3206 says that extension cords shall not be connected to each other. Underwriters Laboratories UL 817 states that cord sets shall not be connected in series or parallel with other cord sets. Many manufacturers of extension cords include warnings in the tags against connecting them in series. There are several reasons for not connecting extension cords in series. Firstly, voltage drop occurs. Each connection in a series introduces resistance, which reduces the voltage available at the end of the cord. Secondly, overheating may occur. The gauge of wire in an extension cord is designed for the specific length of the cord. Connecting multiple cords in series can exceed the amperage rating of the wire and cause overheating. Thirdly, GFCI malfunction could occur. Ground fault circuit interrupters are required on construction sites. A GFCI connected to a series of extension cords may not function properly if there is a ground fault on any of the connected cords. Using a single long extension cord instead of multiple connected cords eliminates the risk of tripping hazards and other accidents. To elaborate on the NEC regulations, the National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is not itself a law, but it is often adopted by state and local jurisdictions, making it a legal requirement. The NEC is updated every 3 years to reflect changes in technology and best practices. Article 400 of the NEC covers flexible cords and cables. This article provides requirements for the types of cords that can be used, how they can be used, and where they can be used. Section 400.7 specifically addresses the uses permitted and not permitted for flexible cords. As previously stated, 400.7a prohibits using flexible cords as a substitute for the fixed wiring of a structure. This means you cannot use an extension cord in place of permanent wiring. Doing so is a violation of the code and can create a safety hazard. The NEC also prohibits connecting flexible cords in series, as detailed in Section 400.7c. Connecting extension cords together creates a longer cord, but it also introduces several potential problems. The NEC aims to prevent these hazards by prohibiting this practice. Now let's delve deeper into OSHA regulations. The Occupational Safety and Health Administration, or OSHA, is a federal agency responsible for ensuring safe and healthful working conditions for workers by setting and enforcing standards and by providing training, outreach, education and assistance. OSHA standards are legally enforceable requirements. Section 1926 of OSHA regulations covers safety and health regulations for construction. Subpart K of this section addresses electrical safety. Paragraph 1926.405 specifically prohibits connecting extension cords to each other. This regulation is in place to protect construction workers from electrical hazards. The OSHA regulations, which are the Michigan Occupational Safety and Health Administration regulations, mirror the federal OSHA regulations. Specifically, Rule 408.4196 references 29 Code of Federal Regulations 1910.305, which addresses wiring methods, components, and equipment for general industry. This rule reinforces the prohibition of connecting extension cords together, ensuring consistency with federal standards within the state of Michigan. Similarly, the Cal-OSHA regulations, or California Occupational Safety and Health Administration regulations, also prohibit connecting extension cords together. Regulation 8 Code of California Regulations 3263 explicitly states this prohibition. California has its own set of occupational safety and health regulations that are often stricter than federal OSHA standards. This regulation reflects California's commitment to workplace safety. UL 817 is a standard for code sets and power supply codes published by Underwriters Laboratories, or UL. UL is a global safety certification company that tests and certifies products to ensure they meet safety standards. UL 817 covers the safety requirements for code sets and power supply cords intended for use in electrical appliances and equipment. The standard includes requirements for the construction, performance, and marking of cord sets. It also includes requirements for protection against electric shock, fire, and mechanical hazards. UL 817 explicitly states that cord sets shall not be connected in series or parallel with other cord sets. This requirement is in place to prevent electrical hazards such as overheating, electric shock, and fire. The standard helps manufacturers design and produce safer cord sets and power supply cords. The warnings provided by manufacturers on extension cord tags serve as a crucial reminder of the safety precautions that should be taken when using these cords. These warnings often highlight the dangers of connecting extension cords in series. These warnings are based on the potential hazards associated with this practice, such as voltage drop, overheating, and GFCI malfunction. Manufacturers place these warnings on their products to ensure that users are aware of the risks involved and to encourage them to use the cord safely and responsibly. Ignoring these warnings can lead to serious injury or property damage. Voltage drop is a significant concern when connecting extension cords in series. Every electrical conductor, including extension cords, has some amount of resistance to the flow of electricity. When you connect multiple extension cords together, you increase the total length of the conductor, which increases the total resistance. This increased resistance causes a drop in voltage along the length of the cord. The longer the cord, the greater the voltage drop. Voltage drop can cause electrical equipment to operate efficiently or not at all. It can also cause the equipment to overheat, which can lead to a fire. The amount of voltage drop depends on several factors, including the gauge of the wire, the length of the cord, and the amount of current flowing through the cord. To minimize voltage drop, it is important to use the shortest possible extension cord and to use a cord with a gauge of wire that is appropriate for the amount of current being drawn. Overheating is another major concern when connecting extension cords in series. The gauge of wire in an extension cord is designed to carry a specific amount of current. When you connect multiple cords together, you increase the total length of the conductor, but you do not increase the gauge of the wire. This means that the wire may not be able to handle the amount of current being drawn, which can cause it to overheat. Overheating can damage the insulation on the wire, which can lead to a short circuit or a fire. It can also damage the equipment that is plugged into the cord. To prevent overheating, it is important to use the correct gauge of wire for the amount of current being drawn. You should also avoid overloading extension cords by plugging too many devices into them. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock. They work by monitoring the current flowing through a circuit. If the current flowing into the circuit differs from the current flowing out of the circuit, the GFCI will trip and shut off the power. This difference in current indicates that some of the current is leaking to ground, which could be through a person. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and construction sites. When you connect multiple extension cords in series, you can create a situation where the GFCI may not function properly. The added resistance from the connections can interfere with the GFCI's ability to detect a ground fault. If there is a ground fault on any of the connected cords, the GFCI may not trip, which could result in a serious electric shock. In addition to the electrical hazards, connecting extension cords in series can also create tripping hazards. Multiple cords lying on the ground can be difficult to see and can cause people to trip and fall. This is especially a concern on construction sites where there is a lot of activity and potential for obstacles. Using a single LAN extension cord eliminates the risk of tripping hazards. Using a single extension cord of the appropriate length is the safest and most efficient way to provide power to electrical equipment. It eliminates the risks associated with connecting multiple cords in series and reduces the potential for tripping hazards. When choosing an extension cord, it is important to select one that is long enough to reach the equipment you need to power without having to connect multiple cords together. You should also choose a cord with a gauge of wire that is appropriate for the amount of current being drawn. In summary, it is not recommended to connect extension cords in series due to the risks of voltage drop, overheating, GFCI malfunction, and tripping hazards. Safety codes such as the NEC, OSHA, MOSHA, and Cal-OSHA prohibit this practice. Manufacturers also include warnings on their products against connecting them in series. For optimal safety, use a single extension cord of the appropriate length and gauge for your power needs.